Hello, space enthusiasts! Today we'll explore an incredible discovery made by ESA's Gaia Space Telescope, which is rewriting the history of our galaxy. Let's dive in. Our galaxy has collided with many others in its lifetime. ESA's Gaia Space Telescope reveals that the most recent of these collisions took place billions of years later than we thought. The Milky Way has grown over time as other galaxies collided with and were consumed by it, triggering ripples that affect how stars move and behave. Gaia aims to unravel this history by studying these ripples, pinpointing the positions and motions of over 100,000 stars. We get wrinklier as we age, but our work reveals that the opposite is true for the Milky Way. It's a sort of cosmic Benjamin Button, getting less wrinkly over time, says Thomas Donlan of Rensselaer Polytechnic Institute and the University of Alabama in Huntsville, lead author of the new Gaia study. The Milky Way's halo contains stars with unusual orbits, believed to have joined our galaxy during a last major merger known as Gaia Sausage Enceladus, GSE, dated to between 8 and 11 billion years ago. However, new Gaia data suggests another merger may have occurred less than 3 billion years ago, called the Virgo radial merger. For the wrinkles of stars to be as clear as they appear in Gaia data, they must have joined us less than 3 billion years ago, at least 5 billion years later than previously thought, adds Heidi Jo Newberg, also of Rensselaer Polytechnic Institute. This finding challenges the idea that the unusual stars originated from the ancient GSE merger, suggesting instead a more recent event, the Virgo radial merger, involving a dwarf galaxy colliding with the Milky Way around 2.7 billion years ago, is likely responsible for these stars. The Milky Way's history is constantly being rewritten thanks to new data from Gaia, says Thomas. Our picture of the Milky Way's past has changed dramatically, and our understanding of these mergers will continue to evolve rapidly. Gaia's mission is transforming our view of the cosmos, providing a comprehensive dataset of the positions, distances, and motions of around 1.5 billion stars. Gaia is a hugely productive mission, says Timo Prusti, project scientist for Gaia at ESA. Results like this improve our understanding of the events that shaped the Milky Way, helping us better understand galaxy formation and evolution.